Hello students, I hope you all are doing well. Welcome to our next class. I am your class 10 physics teacher, as you all know. Now in this class we will learn about our mirror formula. In the last class we have learned 6 ray diagrams which were very important for us. In this class particularly we will focus upon our mirror formula as well as our magnification formula. Okay? Student, now whatever I say is very important for your exam purpose and each and every exam, okay? Numericals will come from this particular topic, okay? So for that you need to keep attention, okay? Mirror formula is very important, okay? What exactly is mirror formula? Mirror formula states that when you are having image distance, object distance as well as focal length, image distance, object distance and focal length, then if suppose any one quantity you don't know, suppose you have image distance and object distance, you don't know focal length, then you can find it out. Suppose you have focal length as well as image distance, you want to take out object distance, you can do that as well. The relation between image distance, object distance and focal length is known as mirror formula. Again, the relation between image distance, object distance as well as focal length is called mirror formula. Let me write here. The relation between image distance, object distance and focal length is called mirror formula. Now, first of all we will learn what exactly is object distance, what exactly is image distance and what exactly is focal length. Let me remind you, you know, but let me remind you in this session. Okay. Students, here as you can see, the distance between P and F is called focal length. It's called focal length. Okay, did you got it? Yes. Then the distance between pole and center of curvature from here to here. The distance between pole and center of curvature is known as your what? Image distance. This is image, right? Let me write here. This is suppose. Yes, this is our image. So this is our image distance. Okay. Now you can see at last you are having one. So here, distance between object and pole. The distance between object and pole is called as what? Object distance. Did you got it? I hope you all got it, right? Okay. Now you learn. Now we will discuss about the symbols. What is the symbol for object distance? Symbol for object distance, I write short form OD. Symbol for object distance is always u. Okay, symbol for object distance is always u. Symbol for image distance is always v. What it is, student? V. Okay, then symbol for focal length, suppose symbol for focal length is small f. Small u, this is also small v, this is also small f. Now you got symbols, now you got the distance idea, everything. Now we will write formula. Formula is 1 by v plus 1 by u is equal to 1 by f. You can see clearly, right? 1 by v plus 1 by u is equal to 1 by f. This is our mirror formula. Okay, regarding this, let me give you one small numerical. I hope from there you will be clear and try to do it by yourself. Numerical is, from a book we will take an object kept 25 centimeter apart from a concave mirror. An object is kept 25 centimeter apart from a concave mirror. Then its focal length, whereas its focal length is 15 centimeter. How much? 15. Whereas its focal length is 15 centimeter. Now the question is, at which place we will keep the screen so that we will get the image. Student, this should be done by you, by yourself. You people will do. Let me give you some insights. An object is kept at 25 centimeter apart from a concave mirror. So you got your object distance, that is 25 centimeter. Then its focal length is around 15 centimeters given. The focal length is 15 centimeter. Now he is asking, where should I keep the screen so as I'll get an image? So as I'll get an image that is of 15 centimeter. So as I can get image wherever, at which place we will keep a screen. How can you determine? You have to put the formula here: 1 by v, 1 by v, 1 by u, and 1 by f. Now you might have an idea, sir. If I keep directly the value u, that is 25, and directly the value of f, that is 15, will it be correct? No, it will be wrong. To understand this, we need to learn sign convention. That one I am going to teach you now. We will learn now sign convention as well as magnification formula, so that in the next class we people will be discussing numericals and all. So did you understand till now? This kind of problems we can solve by putting this particular formula. But before putting this formula, you need to learn another most important topic, that is your sign convention. Okay, students. What exactly is sign convention? Okay, right here. Students, sign convention for concave mirror. That's what I am going to teach you. When we talk about sign convention for concave mirror, what you need to write is what are the rules, what are the regulations, and what kind of signs we have to follow. Sign in the sense plus or minus. Those things we need to write in front of each and every number. So that's what we need to follow here. So here, and remember, this is the most important one. See what I said, that mirror formula is most important one. Now I am saying this is most important one. Why I am saying is, mirror formula if you want to put, then you must place the values by comparing it to sign convention, or else the values will go wrong and you will get wrong answers. So sign convention need to be understood, then only you will place the values in that particular numerical. Okay? So let me draw. Student, first you will say that all the distances should be measured from the pole. You should not measure from object to pole. No. You will measure the distance from pole to the object. All the distances should be measured from the pole. This thing you need to understand. This is your first point. All the distances should be measured from the pole. Okay? Second point. The distances measured in the direction of incident light to be taken as positive, and those measured in the direction to be opposite incident light to be taken as negative. Whatever diagram we are drawing till now, what here object is there, so the ray of light is coming from this direction. Here the ray is falling, right? From this direction the ray of light is falling upon the concave mirror. But how we are measuring the distance? From pole we are measuring the distance. Ray of light is coming in this way, and we are measuring in that way. So here we have to take it as negative. So object will be always kept in front of your what? Mirror. So the object distance you will measure against the flow of light. So whenever an object distance is given 25 or 30 or 15, you must take it as minus 25, minus 30 or minus 15, because we have to measure object distance negative, like in the opposite direction to the flow of the light. Okay? Now, if image is formed here, suppose image formed here. Now, image distance is also here only, this one only. This is what our image distance. But what exactly you need to understand is, if in the real world image is formed, then you should take that's also minus, because you are measuring in which direction? From pole to the image. Okay? One thing is very clear, if you are measuring distance against the flow of light, you need to take it as positive. Suppose the image is formed here. Then how you will measure? From pole to here, right? And the direction of light is also okay. You are going with the flow of the direction of light. So in that case, you will take it as positive. And next, the heights which you are measuring above the principal axis. Heights which you are measuring above the principal axis will be taken as positive. Heights which are measured above the principal axis will be taken as positive, and heights which are measured below the principal axis will be taken as negative. This is positive, this is negative. So what we have understood, object distance will always negative, object height is always positive. Image distance can change from positive to negative. Like, it depends on the position. If it is in front of the mirror, then it will be negative. If it is inside the mirror, then it will be positive. Now focal length. Focal length for concave mirror is also always negative, because focal length is in real world, right? So focal length will also always be negative. Okay students, thank you. We will meet our next class.